Hello everyone, myself Mr. S. Kurumurthy, working as Assistant Professor in the Department of Mechanical Engineering in Marri Laxman Reddy Institute of Technology and Management in Dundigal. So today we will be going to discuss about non-destructive testing. It is also called as non-destructive evaluation or non-destructive methods. Okay, let us discuss about the some of the course objectives of non-destructive testing. So first course objective, to make the students understand importance of NDT in quality assurance. Basically this NDT process, it is mainly applicable to detect any defects which was there in the materials. So in the quality assurance department, there the quality inspection will be conducted. There it plays a vital role, so that every student, the objective will be, uh, he should understand the importance of NDT, and he should know the various basic NDT principles along with its applications, limitations, codes and standards. Okay, and if you know the technique only, then where it is applied and what are the some of the limitations will be there. So there it will be applied directly, so that that NDT process or method, it is enabled to a component or material to detect any defects. To equip the students with proper competencies to locate the flaw in a various materials or products. So whatever the materials or products which are manufactured, it can be by due to the error of a machine or a man, some of the defects will be, it cannot be detected directly. So that with the proper competencies, we have to locate the flaws and defects in a material, so that the material can be utilized properly. And the fourth one, to make the students to be ready to use NDT techniques for in situ applications. In situ applications means wherever the part are going to be functioned, at that function of the part also, there also we can inspect the material with that, with some different methods. And to inculcate the knowledge of selection of a right NDT technique for a given application. Depending upon the application, the NDT technique must be utilized. Now let us discuss about the course outcomes of non-destructive testing. So to compare the differences between various visual inspection techniques and apply the same components to be inspected. So there are the different types of inspection techniques depend upon. Visual inspection technique is the oldest and first method, so that whatever the flaw or defect that can be found out in the initial stage, that is visual inspection, right? And to recognize the importance of penetrating testing in NDT with the understanding of procedures involved in the penetrating methods. So there are basically two types of penetrating methods will be there: liquid penetrating testing and magnetic particle penetrating testing. And in that, we have to know the importance of each and every penetrating testing, so that wherever there is an applicable, we have to apply the technique and then get the results. To interpret the images and results obtained from thermographic technique and eddy current testing. Even from the thermographic technique also, defects will be found out by passing the electrical signals due to the temperature differences. So in the eddy current and thermographic technique, the results will be obtained from them. And to evaluate, interpret the results obtained in ultrasonic inspection and acoustic emission technique. In the ultrasonic inspection, the sound waves will be sent to an object, so that where there is a defect, the sound reflection will be plays a major role, so that it can be early detected. And then in the acoustic emission technique also, and to explain the techniques involved in radiographic testing, various advancements of radiography. By using of radiations also, we can find out a defects in a radiographic testing machine, so that it can be minimized, so that the product usage will be increased. So these are the 5 units we'll be having in the non-destructive testing. The unit 1, it gives the introduction about visual inspection methods and NDT versus mechanical testing, need of NDT, relative merits and limitations, various physical characteristics of the materials and their applications in NDT, visual inspection, especially in visual, unaided and aided. In this aided boroscope, we will be discussing about boroscope, videoscope, special features of boroscope, and how the selection of boroscope should be happened. And then we will be discussing about the optical sensors, microscopes, replication microscope technique and applications. So in the unit 1, we'll be discussing about the complete visual inspection methods. And in the unit 2, liquid penetrating testing and magnetic particle testing. In this, these are divided into two parts: liquid penetrating testing. In this, we'll be discussing about the principal types and procedures, and what are the penetrants and what are their characteristics, and different types of emulsifiers, solvent cleaners, developers, properties, and their forms, and what are the different equipment and what are the different advantages and limitations of liquid penetrating testing will be discussed here. And at the same time, along with this thing, some of the applications where liquid penetrating testing is mainly utilized and applied, so that the whatever the results we get to minimize the defects, that will be useful to us, right? Next, magnetic particle testing, will be discussing about the principle, theory of magnetism, magnetizing current, magnetization methods, magnetic particles, procedures, interpretation, relevant and non-relevant indications of a magnetism, and then residual magnetism. Demagnetization is also be done after indicating the magnetic field, and what is the need, what are the different methods, applications, and limitations, and magnetic rubber inspection, magnetic printing, and magnetic painting. So this will be discussing under the unit 2. And the third unit, it comes under thermography and eddy current testing. Thermography, it deals with the principle of temperature. Okay, whenever the thermography, when we discuss about the thermography, we will discuss about introduction, principle, contact and non-contact inspection methods, active and passive methods, liquid crystal concept, and examples, and advantages and limitations. And in the eddy current technique, the principles of eddy current testing elements, sensing elements, probes, instrumentation, types of arrangement, what are the advantages and limitations, interpretations, and results and applications we'll be discussing about in the third chapter. And the next fourth unit, it will be discussing about the ultrasonic testing and acoustic emission testing. It completely based on the principle of sound waves. The reflection of sound wave, it will detect the where there is a defect in a material. The sound waves will be sent to a one induction, and this electronics ultrasonic testing will be discussing about the principal basic equipment, transducers, couplants, ultrasonic wave, what are the different variables in ultrasonic testing, transmission and pulse echo method, straight beam and angle beam, A scan, B scan, C scan methods, and phased array ultrasound, and time of flight diffraction. And then we'll be discussing about the advantages and limitations of the ultrasonic testing. In the same way, when we come for the acoustic emission technique, we'll be discussing about the introduction, types of acoustic emission signals, how the wave propagation of acoustic emission wave is propagated, and then source location. We'll be discussing about the Kaiser effect, AE transducers, principle and instrumentation, advantages and limitations, and results and applications of the acoustic emission machine technique will be discussed in the fourth unit. And the fifth unit, we'll be discussing about the radiography. That means how the radiations are going to be useful to detect any defects in any material. And we'll be discussing about the principal, X-ray production, gamma ray sources, and tubing materials, X-ray tubing characteristics, interaction of X-ray with the matter, imaging and film techniques, filmless techniques, types and uses of filters and skins, and then real-time radiography, geometrical factors, inward square law, characteristics of film, grainless density, speed and contrast, characteristics curves, and penetrometers, and the same time exposure charts, radiographic equivalence, and fluoroscopy. In fluoroscopy, we'll be discussing mainly on zero radiography, it is so called as, and then digital radiography. It is useful for the film digitization, and direct radiography and computer radiography. Computer radiography, gamma ray radiography, safety in the X-ray and gamma ray radiography. These are the different topics we'll be discussing in the Unit 5. So, for the textbooks that will be followed for non-destructive evaluation or testing, so we will use the main textbook as a Paul Emix, and the title will be in the form of Introduction to Non-Destructive Testing, a training guide. It was a 2005 edition, which will consist of very core and deep knowledge regarding each and every technique. And the next book we followed is Baldev Raj and T. Jayakumar. It was titled as Practical Non-Destructive Testing. In the 2009 edition, it will give detailed topic about the uh, whatever the discussions in the inspection methods. There are different inspection methods, so that will be give in detail in this Baldev Raj book. Okay, these are the references books we can consider for different topics specifically, and it was titled as Non-Destructive Testing Techniques by Ravi Prakash, and then Non-Destructive Evaluation and Quality Control. It is the ASM metal book. You have to refer it if you want more detailed information. And American Society of Non-Destructive Testing also. This handbook is very useful for the very particularly some special methods like radiographic and ultrasonic testing. It will be having very deep in depth of the each and every topic, and these are the references URLs we can easily find out in the YouTube media, so that we can be easily get aware of each and every topics. And next, now we will be getting to the topic of non-destructive testing. Basically, what do you mean by non-destructive testing? It is a method of testing materials without damaging their future usability. So, whatever the material we are going to use to test that defects or flaws, so that we can use it for further use also. Because mainly there is a type of destructive testing. So, what are the main destructive testings are there? To find out any properties, mainly to find out any properties of the material, we'll be testing under tensile test mostly, tensile test, and then bending test and hardness test, impact test. In the similar way, these are the different types of destructive testing. That means the material is going to be destructed in any of the form, so that to find out the properties of that material. Okay, and to know the behavior of the material also, some of the testing techniques will be followed. So in this case, what is happening in the tensile test or bending test and hardness and impact and any further other process, the material will be break into some pieces, so that whatever the properties that will be found out after the destruction of the material. And here in this NDT technique, the material will not be destructed, so that here main intention is it can be reusable after testing also, and the component can be still used after testing. At the same time, this method is mainly used to defect detection and material evaluation. And what is the power? Mainly NDT non-destructive testing is withstanding its no damage and reusability, defect detection and material evaluation. So these are the different properties, different profits which can be held by using the non-destructive testing methods. We can follow the non-destructive testing methods to reach all the basic principles. I mean, these are the following advantages. Okay, and then we'll be discussing about the NDT and mechanical testing. NDT testing versus, there are basic differences between non-destructive testing and mechanical testing. So in this non-destructive testing, we can easily find out defects mainly, right? In the mechanical testing, what we will find out here, we will find out the properties and at the same time behavior of the metals also. Behavior of the materials also can be found out in the mechanical testing. Here in the NDT process, no load is applied, so that no destruction is applied there. But here in this mechanical testing, load is applied so that it can break the material, so that the properties can be withdrawn. And next, here no material is damaged, in the sense, if no load is applied, no material will be damaged. Here the material damage is occur in the mechanical testing. Here no special equipment will be taken care. Here very special equipment will be taken care, because in the testing of any materials, for example, tensile test, bending test, it can be these two tests along with compression test. It can be applied in only universal testing machine, where it is a UTM is a very huge machine, very special equipment to conduct only tensile test, bending test, and compression test. So here in this NDT, no special equipment will be encouraged here, and so that it is very useful for it is one of the beneficial profit. And next one is, it is very non-expensive when compared with the mechanical testing. Okay, and here no less skilled labor is required, and here somewhat skilled labor is required, so that no manual error can be minimized here. So here also less skill less skill labor is required, so that no machine, no, and not a particular detection of the materials can be easily found out. So this is about the differences between NDT and versus mechanical testing. Here, what is the need of a non-destructive testing? So mainly it can benefit the ensure safety, so that it can prevent failures in aerospace, bridges and pressure vessels, etc. And then it can improve the quality, ensure components to meet some specifications, and then it will reduce the cost. It avoids basically a destruction of the parts, no? So we will reduce the cost by there itself, and here we can detect the whatever the flaws or defects which was hidden in the material before the application itself, so that we can easily extend the long life of a material. And we can easily detect the hidden flaws. What are the hidden flaws? Some cracks, porosity and inclusions and delaminations. These are the different property, these are the different defects or flaws which can be detected before itself, before the application of that material into the practice. Next, it can be used in different all stages. Here it can be applied in a raw material, in the manufacturing stage, in the assembly stage, and even in the application stage also. There will be some maintenance time also we will be defining. In this way, the service life of a material can be increased. And where this non-destructive testing is utilized, the different industries, aerospace industries, nuclear industries, power plant industries, and then railways, automobile areas also. These are the different industries where we can apply the non-destructive testing. And then some of the merits and limitations were there. So still it has a huge benefits and very useful inspection methods we followed, but it also consists of some of the limitations, right? First we will discuss about the merits, that means very positive points now, and then the merits. It cannot damage the material, I mean it does not damage the component. It can detect only surface and subsurface defects. It is applicable for the all the materials, not only the metals. It can also be applicable for the plastics, and it increases the reliability and safety, the fast and portable, suitable for field inspection. And some of the limitations were also there. It requires trained inspectors, because at the initial stage and some of the instructions and will be there to guide any instrument which was using for the non-destructive testing method, so that some of the trained inspector should be there so that it can be the evaluation process can be done very flawlessly, right? Some of the methods are expensive here. UT methods, ultrasonic testing method and radiographic testing method, it is very some of the expensive process, expensive methods. And so one of the limitation is interpretation of the results may be subjective here, and surface preparation sometimes required, because whatever the practical material in practice, that will be covered with some dust and machine elements, various parts of a dust can be applied on a material, so that where it is practicing. So to prepare, we have to prepare the surface so that only the deflection, whatever the defects, that can be easily identified by the some of the methods, right? And one of the limitation is certain techniques are material specific. Here, for example, MPT is nothing but magnetic particle testing. It is only applicable for the ferromagnetic materials. So it is these are the very few limitations of the NDT were there. And here the different properties. Next, we will be discussing about the various physical characteristics of the materials. So first property is density. This property is it's mainly utilized in the radiographic testing, and if higher density, it blocks the more radiation. So if the radiation, if it is blocked, there will be a formation of image contrast is happened, so that it can be the property, it should be where there is a higher density only, it can easily blocks the more radiation, and then contrast will be formed, so that the due to the higher contrast only, it can be whatever the defect can be easily detected. And the next part, and the next property, material properties, magnetic properties, it is mainly used in magnetic particle testing, and only ferromagnetic materials like iron, nickel and cobalt, it will respond well. And next property is electrical conductivity. It is mainly used in eddy current testing. So this conductive materials, it creates the eddy current so that it can detect corrosion, I mean cracks in the material. The next property is elastic properties. These elastic properties are utilized in the ultrasonic testing. This wave speed, it mainly depends upon the Young's modulus and density. Okay. And next, surface reflexivity is one of the characteristics of the material. It can be used in visual testing and liquid penetrating testing, and it helps in detect surface cracks, pitting and corrosion. And the last property will be thermal properties. Thermal properties mainly utilized in the infrared thermography, and it uses heat flow differences between the, it can help the locate the defects. There will be heat conduction flow, there will be a flowing of an heat into the material, so that where there is a less response to the heat, that can be detected as a defect. And next, we will be discussing in depth about the visual inspection now. Basically, what is visual inspection? The inspection is done visually, right? And the foundation, visual inspection is the foundation of all NDT process. It is the first and most process which will be applied in the NDT techniques here, and it is commonly defined as it involves in the visual observation of the test specimen to detect the presence of surface discontinuities. So there are discontinuities or defects, it can be taken as a flaws also, right? And even before the advanced methods, there are very advanced methods in the NDT, but it is the first step is always visual inspection only. And there are some of the defects which will be detected in the visual inspection are, first one is surface cracks. Surface cracks can be easily found out. For example, if there is any material is there, if this crack is easily can be found out with the eye of an human eye, okay, naked eye directly. And then even the corrosion of the material, and then misalignment of the, whenever there is an assembly, the misalignment easily it can be detected by visual inspection only. And there are some welding defects also that can be easily detected by our naked eye. That is comes under visual inspection. So what is the procedure? Let me discuss about the procedure also. This inspection process, it may be done using behaviors like first looking, listening, feeling, smelling, shaking and twisting of the materials. And in the principle, the basic principle which will be utilized in the visual inspection is illumination of test specimen with light is usually in the visible region. If the object or the material, if it is illuminated perfectly only, the whatever the defects that can be detected easily. And it also require proper eyesight of the tester. Whoever the tester, he will be testing the material, he should have the proper eyesight so that it can be done very easily. And the surface of the test specimen, it should be adequately cleaned before inspection. Before inspection, the surface must be cleaned. And these are the different this diagram shows that here the technician people, they are using the visual inspection method, and they are testing it is a flawless, I mean, the flaws and defects can be easily detected by visual testing, and this picture indicate that. And here some of the picture which was included because there are some of the visual techniques that can be done by aided is nothing but we'll be using by using some of the instruments also, right? So visual inspection, there are two types of visual inspection are there. Unaided, it is also called as direct visual inspection. It can be done by direct or naked eye. And the second one is so called as aided inspection, aided visual inspection, that is also called as indirect visual inspection. So here unaided direct inspection is nothing but inspection is done with a naked eye, and it is done without any optical aids, without any other instruments that can be used, so that no instrument is used here in the inspection. That process is called unaided or direct visual inspection method. In this aided, now we'll be discussing about the aided visual inspection method. Here some of the instruments will be instruments or optical aids will be used. Those are magnifying glasses, mirrors, boroscope and videoscope, optical sensors, microscope and replication microscope. These are the different aided materials that can be used to detect the defects in a comes under visual inspection, aided visual inspection. In this aided visual inspection, it permits visibility to the areas which are not accessible to the human eye. So where there is a some narrow areas will be there. In that narrow areas, a person can't go and visit the area where there is a defect in a material. So that in that places, the instruments will be utilized. For example, some boroscope and videoscope, optical sensor. These are the different instruments that can be sent through a tube of a some narrow length, and they can be sent into the material, and then defects can be found out easily. And then we'll be discussing about the unaided visual inspection now. What are the requirements, what are the detectable defects and advantages and limitations? So in unaided visual inspection, the basic requirement is good lighting. Natural or LED lighting should be provided, and the surface must be cleaned. The proper inspector, he should have some perfect posture and he should have some accessibility, and he should be pertaining some experience and training of the inspector must be done. So that these are the very basic requirements where the visual inspector can be do the inspection very perfectly. And these are the detectable defects. The following are the detectable defects. Here surface cracks can be detected, and then rust and corrosion can be detected, and weld spatter, porosity, misalignment of the any materials, overheating or discoloration, and burrs, dents and scratches can be found out easily by visual inspection. And what are the advantages? It is very simple and inexpensive way, since we are not using any higher equipment. Any equipment is not used, so that it is simple and inexpensive. It can be done very quickly, so that this quick inspection of larger areas, it can be an advantage to the visual inspection now. Hence here no equipment is required now, so quick inspection must be done. And some of the limitations were also there for the unaided visual inspection. Those are only surface defects can be found out, right? In depth of surface, it cannot be detected by visual inspection. We should use the some of the LPT MPT methods. There are different methods of a NDT, in that we will use the in-depth surface defects can be found out by using special methods. Here surface defects cannot be found out, only surface defects can be found out, but not in the depth. And it cannot detect small micro cracks or internal flaws of a material, and it has a human eye limitations which cannot go further vision. Right. Next, we'll be discussing about the visual inspection and applications. So applications of visual inspection, it will be detecting various surface flaws and discontinuities due to the following reasons. Corrosion. Due to the corrosion, it can be defect can be detected. The defects will be happen by using this following various applications here due to the defects only. And the next, contamination, maybe the contamination happened so that the defect is happened in the material. And then inadequate surface finish, improper joints, welds sealed, and then solder connections and adhesive bonds. Okay, these are the different types of applications where we can easily found out applications by using corrosion, contamination, inadequate surface finish, and proper joints. And now next, what if visual aided are also not enough? If visual aids is also not enough to inspection, then what is the next procedure we have to follow? If physical access to the area which needs to be examined as limited to the visibility, or visibility is limited, if examine area is limited or visibility is limited, what we need to go for the further step. For example, inspection of inner surface of the bolt hole. For example, if you just consider, if there is a bolt hole, okay, and here some internal threads is happened here, okay, in this bolt. So what we will further in the, if any defects or flaws, if it is appear to be present in the inside of a very lengthy bolt, that cannot be easily detected by visual inspection, no. So what is the further step we need to go? And for that process, there are some of the instruments that can be utilized specially, so that even all the inspection methods, whatever the, by using these instruments, we can directly use for the inspection method so that flawlessly. And by using, what are the different inspection aided material that can be used? First one is boroscope. See, this is a boroscope here. It is a tube like structure, very lengthy material, and it is attached to the one of the screen here, and so that it can be sent, this tube can be sent to any detectable region, so the defects can be detected easily in a internal materials. And the next is videoscope. So the same advanced boroscope is so called as a videoscope. Here we are able to record the whatever the cracks that can be made in the material which in practice. And then mirrors can be utilized so that opposite element, reflected defects can also be found out very in a very less diameter hole. So by using mirrors, there the defects can also be detected. Using magnifiers, very tiny objects will be there, for that any crack propagation is happened. For example, any bold material or any threaded part, if there is any crack and it cannot be visualized directly through our naked eye, so that the magnifying lenses can also be used. And to approach in the visual inspection by microscopic level, microstructure level, microscope is used, and the optical sensors are also used as a aided visual inspection to conduct the non-destructive testing. And next we'll discussing about the boroscope in detail. First of all, a boroscope is, it is an optical tool with a tube, eyepiece, and screen on one side, and a lens and camera on the other side. It is used to inspect hard to reach and sensitive areas without damage. Without damaging the part, it can be inspected very easily by having some. These are the tube and eyepiece screen of the different parts of that boroscope. Okay, and what are the different types are there? There are rigid boroscope and flexible boroscope. This rigid boroscope, it can be a straight and limited access will be there, and it can be used only for inspecting cylinders and fuel injectors, hydraulic manifolds, and gunsmithing. And flexible boroscopes are used to it can be bent to a view curves, and connects a camera to eyepiece, and then used for pipes, ducts, and vents, and chimneys also. So these are the different applications of the boroscope. Yeah, it can be applied in an automotive inspection. It can be inspect automotive parts like bodies, engines, and gears also. Okay, and they check weld, welds and cracks and wears. And early issue detection also one of the application. So it helps in spot small issues early to the prevent accidents. So inspected parts without taking them apart, and it can be used to different usage locations. These are used in workshops, motorsports, vintage car care, and they are versatile tool in the automobile professionals also. Right? We will be discussing in depth of the boroscope now. How, what could be the principle, what are the different types, and where there is an usage. The boroscope works on the principle of optical image transmission through the lenses and fiber optics. Right, and this is the procedure how the process of the boroscope is happened. First, light is transmitted into the inspection area, and then reflected light from the object surface enters the optical system, and then image is transmitted through the lenses and then fiber bundles. By after image is transmitted, the inspector he will observe the magnified internal surface on the eyepiece or monitor. In this way, we can easily detect the defect in the boroscope. Okay, so what are the different types of a boroscope now? There is a rigid boroscope, as we discussed earlier. It is a straight metal tube. It gives the high image quality of the materials, of the images of the product, whatever the materials it is used, and it is used where the direct straight line access is existed. It cannot go into the curve path, right? For moving into the curve path, the inspection method, we will use the flexible boroscope, where it is so called as a fiber scope also. It uses as a fiber optic bundles, so that it can move in any curvilinear motion. Right, it can bend through a curved paths. It is used in a pipelines and complex machinery also. And then the third classification, the third type of boroscope is videoscope. It has the miniature camera at the tip, and it displays the images on the screen, and it allows image recording and measurement. And next we will be discussing about the each boroscope in depth now. First we will discuss about the rigid boroscope, later we'll discuss about the flexible boroscope, and then video boroscope. The rigid boroscope, it consists of straight and inflexible tube with an optical lens. In this way, optical lens system, this tube is usually made of stainless steel, and the device is ideally for inspecting straight line and hard to reach the areas. Right, wherever there is a some regions are there, it is very hard to reach those areas. In those regions, the rigid boroscope is utilized so that it can be inspected perfectly. Right, and the design, the rigid boroscope, it has an eyepiece in the viewing, a straight rigid tube and lenses, a light source either built in or external way, and it is often connected to the illuminate the target. Wherever the material is there, it illuminate the target so that flaws can be detected easily. So the different applications here, it is used where the inspection area is easily accessible, and at the same time it should be straight, and such as inspection of external parts of a machine can be done, engines parts can be done, turbine element, what are the elements, components in a turbine, that can be inspected very easily by using a rigid boroscope. And certain industrial components also, for example some boilers and cooling towers, that can also be inspected by using some rigid boroscope. The main key features of a rigid boroscope is it can produce high quality image, which will give you the clarity regarding the defect detection. And then there is a one of the key features, it is a simple in design and robust and cost effective. And it is the third key feature of a rigid boroscope is it is limited to inspecting straight areas or paths. So this is how it look like. It is a straight tube like structure. So this is a field of view where the uh, material can be defects of the material can be detected here. Right, from here the observation can be done by our eyepiece here. Okay, and this is the depth of a field, the light source, whatever the light source, it will gives the through the light source, the illuminated part will be focused on the machine, focused on the element of the material, so that where there is a defect, that can be easily detected by using a plenty of a illuminated light. Okay, and then we'll be discussing about the flexible boroscope. So in the name itself indicates it is flexible. It can move to the any curves or bends in a path. Okay, and then so let us discuss about the flexible boroscope. A flexible boroscope, it is also called as a fiber scope, and it consists of what? Flexible tube. It contains some fiber optic bundles to transmit the image from the inspection area to the eyepiece of an instructor, and then this allows the it to bend and curve through the tight and complex spaces of the material, actually in practice. So the design of a flexible boroscope are equipped with bundle of optical fibers which can transmit images even when the tube is bent. Some models allow for the articulation also, which will give you the user control over the bending of a tip. I mean, we can control, user can be controlling whether in which way it has to move in the optical fiber. This, okay, the tip of the material can be, it can be moved by using a regulator here. It can be done by the instructor here. He can guide the instructions so that by using some of the two buttons over here, we will regulate the this boroscope to move in which direction. The applications of flexible boroscope, it is ideal for inspecting complex internal structures like piping system mainly, and in aircraft engines also. Inspection can be done in aircraft engines mainly, and the areas which are difficult to access with rigid boroscope, where there is an area it cannot be accessible to the rigid boroscope, the flexible boroscope which will be having any benefit. The key features of a flexible boroscope is it can bend and navigate around the curves and obstacles. It will provide the accessible to the areas that rigid boroscope cannot reach. Generally, lower image quality compared to the rigid boroscope due to the fiber distortion. Where there is a lower image quality which will be captured by the rigid boroscope, and where it cannot be bent, or where it cannot be moved in a circular or curved path, there the flexible boroscope is utilized. And the next part is video boroscope. So in this video boroscope, it will consist of some small camera at the distal end, the other end of a probe, instead of a fiber optics to relay the image. And this camera sends the live video to display screen, allowing it for the detailed real-time inspection in practice. So the design it consists of a flexible rigid probe and a small camera at the tip, somewhere here at the tip, and the display monitor. In this display monitor, and the most videos group come with the articulation controls to maneuver the camera tip. So these are the different user control options were there, so that we can direct the probe in a direction where we need to do the inspection. So it also consists of, I mean, it has a wide applications are there. It is widely used in industrial maintenance, automotive inspection, aerospace industries, and the inspection of turbines, pipelines, and engines. And there are some of the key features are there. It can produce high quality image resolution images. One of the feature is real time video feed on a monitor, and it is a capable of capturing images and recording videos for future analysis. And the next key feature is flexible articulation allows the camera to navigate through complex structure of any material, so that any structure, so that where there is a defect in very complicated parts also, this video boroscope helps in find outing the flaws or defects in a material. Right, now we'll be discussing about the main components of a boroscope. But just before, we discussed about the different types of boroscope, and will be mainly overall components. The eyepiece or display monitor, where the operator it views the images. Insertion tube, it is flexible or rigid type. It is inserted into the inspection area. So the object lens, it is located in the distal tip, and it captures the images at the end of a probe. And the next one is light source or fiber optical bundle. it illuminates the inspected area. The control section, it handles the articulation, it focus and other controls of a probe will happen so that very minute distant particle defects also can be found out. And the articulation mechanism, it allows the bending of a distal tip of a maneuverability. And then camera sensor, if boroscope, video boroscope, in the case of video boroscope, the camera sensor will be there. It converts optical signal into digital signals, optical images to digital signals. And it consists of cable or power supply. It connects to the external monitor or recording device. And boroscope and videoscope are similar to it. Advanced boroscope, it is also called as an video boroscope. The basic principle or common procedure will be there. So we'll be discussing about the inspection procedure of boroscope and videoscope now. So the inspection procedure will be, so whatever the material, the inspection area, that has to be cleaned first. The cleaning of inspection opened, if required we need to clean it. And then second procedure will be, we have to select the suitable boroscope type and then diameter of the probe. And then we have to insert the probe slowly into the component. And then we have to adjust the illumination and the focus. Where there is an we need to focus on the defected area, we have to illuminate it. In case of if darkness of the material in practice is happened, their illumination we have to increase it. We can rotate or bend probe for the full coverage. So observe defects such as cracks, corrosion, wear deposits, and we can capture images and videos for the documentation process. So these are the images that can be used to know the procedure for the inspection by using a boroscope and videoscope. Here, see, the person is inserting a probe, and here in the screen he is observing some of the defects we will be find outing in the screen, right? In this video inspection also, here the probe has to be inserted in a pipeline, and then through the regulator of this right hand, we can easily regulate the whatever the probe that is moving into it. And then with this image area, I mean display unit, we can easily find out the defects can be which are there in the material. And next, the boroscope and videoscope applications. So it has a wide applications. We'll be discussing about the very few applications now. And aircraft engine turbine blade inspection, it can be done. And boiler tube inspection, internal weld inspection, automotive engine cylinder examination we can be done. And pipeline corrosion detection is easily detected by the NET principle and by using boroscope and videoscope. And heat exchanger and tube inspection, these are the different images where the inspection is going on, right? It indicates, see here by using the boroscope, he is inserting the probe inside an material part to detect the defects here. And then here also some of the huge machine is there. He is some of the technicians for working on it to detect the any defects by using this one. And here videoscope is utilized here. It is used, the procedure of a videoscope is used to detect the defects here. And then these are the different images where the inspection is going to be done. And see here in this one, here very narrow hole, for example, if there is a narrow hole, the probe has to be inserted in this way with good illumination, so that the perfect illumination, it will give you only clear vision, so that the defects what are there in the inside a hole, it can be detected very easily. And here even in the very huge engine part, very complicated engine part also, it can be easily detected by a videoscope or advanced boroscope. Okay, advanced boroscope is nothing but directly a videoscope only. Okay, and it can be easily detected by using this boroscope and videoscope. And now we'll be discussing about the mirrors and magnifiers, which are the aided techniques that can be used in non-destructive testing. Mirrors are used in the NDT technique. These mirrors, so what is the purpose of mirror now? The inspection mirrors, these are used to view inaccessible or hidden areas mainly. At the such as backside of the well, it cannot be detected directly, so that this mirror can be utilized. And inside a corner and under structures and around pipes, these are the different areas where the mirrors are utilized. And the basic principle of using mirror is they work on reflection of light, allowing the inspector to see the surfaces that cannot be viewed directly. So the applications, there are different applications were there. And backside weld inspection can be done by using a mirror or magnifier, and internal corners of a pressure vessels, pipe joints and flange connections. And structural fabrication checks also can be done by using these mirrors and magnifiers. So these are the figures which indicates how the inspection is done by using a mirrors here. Okay, here the light is falling onto the some smooth surface. If it is reflected in this way, so due to that reflection, the observation can be done and the defects can be detected by using that reflection of a light. Here also, where it is observed in the case of a rough surface, here it is a smooth surface. The reflection of light is different from here and here to here. In this way also we can easily find out the defects in mirrors. And here see here this image also which indicates this image, it examines that by using some mirror he's find out in the internal defect in the whole process. In the whole internal defect of a hole can be whatever the cracks that is present here, that is visible in the mirror. It's showing the defect in the mirror itself. And next we'll be discussing about the magnifiers. So basically what are magnifiers? Magnifiers are nothing but whatever the area that is not accessible, I mean not able to visualize perfectly, that can be entered into enlarging very small areas also by using magnifier that can be approached. So mainly magnifiers are used to enlarge small defects, so that what are the defects that can be easily found out: cracks, pits, porosity, surface irregularities can also be cleanly observed here. And what is the basic principle of a magnifier here? Here it works on the basic principle of optical magnification, that using the convex lenses it can produce what enlarged vertical image of the inspection surface. So that there are different types of magnifiers that can be used in a non-destructive testing process, that is hand magnifying glasses. 2 by 5 size will be there. It is mainly used for the basic inspection procedure. And there is next one is pocket magnifier. It can be used to detect any portable small lens. It will be consisting of very small lens. It is utilized. Pocket magnifier, it is mainly utilized as a portable small lens and illuminated magnifier, which will be built-in light illumination also. And then measuring magnifier or scale magnifier, it is used to mainly measure the crack size, how much crack size is happened. So see here, by using some of the magnifiers the defect can be detected here. Okay, and here also by using good illumination the defects also can be detected here by using some magnifiers. And the next topic we'll be going to discuss about is optical sensor. Optical sensor, these are widely used in non-destructive testing to detect defects and measure dimensions and monitor material behavior using a light based techniques. And these sensors convert light signals, I mean it can convert intensity, wavelength, reflection or phase into electrical signals for analysis purpose. These optical NDT methods are non-contact, fast and highly accurate. And the working principle behind the optical sensors is it based on the mainly some of the following reasons. So first one is reflection of light from the material surface. So whatever the light is reflected here, due to that reflection of light only inspection is done. And this absorption and scattering light inside a material, and interference or phase change in the reflected beams, variation of the optical fiber signals due to the strain or temperature. Whatever the received light that is converted into an electrical signal processed to detect the defects in the materials. And how the same image here, the image indicates that, see here, whatever the laser generator, uh, it emits the radiation, I mean laser light onto the material surface where the laser is heated area is happened. This heated region that can be easily captured by the infrared camera, and that camera images it will give the thermographical images for the inspection purpose. Okay, here the laser or heater source, it heats the material. The laser, whatever the laser generator, it will heat the material, and then infrared camera, it detects the emitted thermal radiations. Whatever the thermal radiations which are emitted by the surface, it can be detected by infrared camera. And then thermal image acquisition, here, see here, there is a thermal image here, this colors indicates that thermal image. Okay, it converts the radiation into the detect any map of the material where the thermal image can be detected easily, and then defects can be found out. And here hidden defects disturbs the heat flow. Where there is a disturbance to the heat flow, those are considered as a defect. So that defects can be easily whatever hidden defects can be easily detected by this appearing as a hot and cold regions. So this is the common optical sensing technique in the NDT, which are so called as infrared thermography, and which has main applications in the NDT. So our optical sensors, it has a variety of applications, wide applications in NDT. It can be easily to detect the surface crack detection using a laser scanning. It can also be used in the application of weld inspection using a machine vision cameras, and pipeline structure monitoring with optical fiber sensors, thickness measurement using optical methods, and composite material inspection also be done by this using a optical sensor. See here, the cables are inserted so that whatever the thermographic, I mean, see here, in the same way the laser sharpening lens will be arranged here, so that the optical sensor which will send the signal, so that the heating element, it will give you the coloring, decolorized figure, so that this decolorized figure, it will give you the considered as a defect in the detection of any material. So let us discuss about the microscope also. It is the one of the important optical instrument used in non-destructive testing to examine very small surface defects that cannot be seen with our naked eye or simple magnifiers. They provide magnification, high resolution to study cracks, corrosion, weld quality, and then coatings and surface finish without damaging the component. It can be easily to detect the any crack, corrosion, weld quality. And the basic working principle of a microscopes, it works on the principle of optical magnification using lenses. And if the light falls on the test surface, reflected light passes through the object and eyepiece lenses. The next point is the lenses enlarge the image many times. This inspector observes the microscopic defects easily and clearly also. There are different types of microscopes that is used in NDT, or optical metallurgical microscope. The second one is stereo microscope, or mainly this is so called as inspection microscope, digital microscope, and portable field microscope. So it has a wide applications in NDT. Are there surface crack detection in metals, weld bead inspection, corrosion pit corrosion pit examination can also be done, and then coating thickness, surface finish study, electronic PCB inspection, printed circuit boards also can be inspected by using microscope only. This dye penetrating indication examine also can be done. So it has some advantages. It can detect very small defects, high magnification and clarity, non-destructive self-examination, and digital recording possible, whatever the modern microscopes are now utilized. And these are the different parts of a microscope. It is the eyepiece, tube, and optical lenses. These are optical lenses. We have to change the lens to view the exact particular microscope here, and this is just a stable stage where the metal can be kept here. By using this microscope, a variety of defects can be found out very easily, and at a microscopic microstructure level also be find out. In the next lecture, we will be discussing about the liquid penetrating testing and magnetic particle testing. Thank you.